Hello, dear aspirants. This is Dr. Saurabh sir's class. We are solving the CSIR NET 2024 questions from June. So this question is from our continuity search activity. So it is our from real analysis, and the question says us that let K be a subset of R, which is not non-empty, and our the function f, which is given from our from k to k, be continuous such that this thing is given. Yeah, and this thing is given. My mod of x minus y is less than equals to fx minus fy. Mod of fx minus xy. Okay, for all xy belongs to k. So now, so we have to think about these four options. Which of the following statements are true? So option A tells us that F need not be surjective. Okay. So option B tells us that F must be surjective if our domain is restricted. That is my close 01. Okay. So now for our C, they told us that will be F is injective and our F inverse. Okay. F inverse which is going from Fk to K is continuous, and option D tells us that it need not be continuous. Okay. So firstly, I want to think about the thing that our yeah. So they have given that our mod of x minus y less than my mod of fx minus fy for all x comma y belongs to k. So after that, what can be done? We can easily see that our k is what? K be a non-empty subset of R. Yeah. So then we can see that our mod of fx minus fy by mod of x minus y, that's y, no? Yeah. That will be my less than 1, less than equals to 1 for all x and y belongs to k. So now for this thing, we can easily see that our mod of fx is less than equals to 1 for all xy belongs to k. Yeah. So for this, as our mod of fx is greater than equals to 1, so our mod of fx will be greater than 0. So our fx is what? Fx is strictly increasing, we know that. Now let us keep it here and think about our option A. They told us that F need not be surjective. Okay. So if we take a domain, that means if we take our K be this, then and let us take our Fx as e to the power x. Then we will get what? Our F is going from K to K. Our e to the power x is strictly increasing and it's satisfying all other the conditions, but our e to the power x equals to 0 does not have a solution in k. So our f need not, so our f cannot be surjective here, so our option A is my true. F need not be surjective. Okay. So I want to write that. Yeah, yeah. So our option A is true. Now we will think about our option B. So they have restricted the domain as our K is my close 01 now. So for the closed 01, my K is this now. So what can be done here? Okay. after this part we can get, so our a, they given us that our a from k to k be continuous, and according to the given condition our, yeah, so I want to tell that we are now at our this point our mod of fx is less than equals to 1. So that, so we mean here f dash x is my greater than 0 for all x y belongs to k, and so our fx is strictly increasing here. Now strictly increasing over k. So now what will be the range of f? So my range of f will be what? That will be my mod of f0 minus, yeah, no, that will be my comma, yeah, mod of, hey, sorry, that is from our f0 to f1. Now for all x and y belongs to k, we can see that our mod of x minus y is less than equals to our, this is given. So if we take those things, that means which is my, okay, let us put x equals to 0 and y equals to 1 here. No, I want to put the reverse in, put in reverse order. Okay. So then we will get one mod of 1 minus 0 less than equals to my, it is this. No, that will be my 1 and y will be, yeah, 0. So we will get that 1 is less than equals to mod of f1 minus f0. Okay. So as we got this, so our the range, our the say, sorry, the distance of this and the distance of this is less than it, so we can easily see that that is my, also that will be less than 1 minus 0, so it will be my less than equals to 1, so our mod of f1 minus f0 will be equals to 1. So we can think, as this is my strictly increasing function, we can take that our f1 will be 1 and our f0 will be 0. We can take that. Then what will happen? So our function must be surjective if our domain is my 0 1. Yeah, so our option B is correct here. So now we have to think option C or D. Either C is true then D is false, or either D is true then C is false. But okay, let us check about that the f is injected then, but and our f inverse is continuous. So we can see that we have got this thing. Our f from k to k is continuous, and from this thing we got f is my strictly increasing. So our f will be what? Our f will be 1 1. So now, so our the inverse, which means the set of the functions inverse will exist. So that can be written as our f inverse if k, from fk it goes to our k. So now from this condition we will get what? We can get this thing will be as for our, in for our given condition, the domain, the conditions of the domain is here and the range is here. So we can again do the thing, because our, this will be for the function f, this will be my domain part, and this will be my range part. So if we get this condition, now after getting this condition we can tell that our function f inverse is now ellipsis continuous, because when our ellipsis condition is satisfied, when a function satisfies the ellipsis condition, then we get k here, and k must be a real number, and those things are occurred. So in this case there only one is exists here. So our f is ellipsis continuous. That implies what? As our f inverse is ellipsis continuous, so our f inverse will be my uniformly continuous, and as it is uniformly continuous, it will be continuous all as well. So we can tell that our option C is also true. And so after this our immediate cancellation will be done for our option D. So our correct options of this question is my A, B, comma C. Okay. Hope you understood. Thank you guys.